The next thing to think about with isotopes is that in nature, they don't all exist in perfectly equal amounts. We don't have, well, with carbon, and this happens for most elements actually, there's normally one isotope that is really, really common. And most of the atoms in a sample are made of that isotope. And that's true for carbon-12 here. So we can see carbon-12, whenever there's carbon in nature somewhere, making up our bodies, there's lots and lots of carbon inside humans. 90, we can see 98, nearly 99% is all carbon-12. And there's only about 1% carbon-13 and a lot less than 1% carbon-14. So which means if we have a chunk of carbon and it might be the carbon in our lead pencil, because that's what we use to write with now, since there's no longer lead in pencils. We've got our chunk of carbon. That means nearly all those atoms are carbon-12. There are a few carbon-13s and barely any carbon-14s. And on the periodic table, you might have noticed there's a second number down the bottom that seems like the mass number, but it's not exact. It's always in a decimal form. And this is called the relative atomic mass. And this tells us information about what's the average mass of a carbon atom when we have a natural sample of it in real life. So to calculate that number, what they do is we take the mass numbers of all the different isotopes. So we've got mass 12, mass 13, and mass 14, and they take an average of that, but we take into account it's an average mass of the natural isotopes. But they take into account how common they all are. So remember, carbon-12, really, really common. Carbon-13, there's not much. And carbon-14, hardly any. Not very mathematical, but that's how many there are. So it's an average mass, and it's called a weighted average. Or in other words, it's including how common each isotope is. And another name for that is abundance. Abundant means common, so the abundance is how much of that isotope. So we can see for carbon, its relative atomic mass is pretty close to 12, because most carbon atoms weigh 12, but a few carbon-13s and a few carbon-14s mean the average carbon atom is a little bit more than 12.